2, 1. All right, our first step is always to balance our equation. Here I have 1 potassium, 2 potassium. So I will need to change this coefficient to 2. Now I have 2 potassium, 1 potassium. That's 1 sulfur, 1 sulfur. It's balanced. Good to go. Now, let's read our question. It says, calculate the mass in grams of potassium required to react completely with 0.8 moles of sulfur. So, we're going to write our given on the left. So, it's 0.8 moles of sulfur. Now, we have to convert this moles of sulfur to grams of potassium. Up here, I have your stoichiometry pathway. Grams of A, moles of B, grams of B. A is what we're always given. In this case, we are given moles of S. Moles of S is moles of A, in this case. Right? And it wants grams of potassium. So we have to get to grams of B. So we're going from moles of A, going all the way to grams of B. So we have to do all the steps in between. So I have to convert the moles of A to moles of B by multiplying by the molar ratio. So let's do that. We're going to convert the moles of S multiplying the molar ratio. What's on top is always what we're trying to find. In this case, we're trying to find our potassium. So we got to find moles of K. And whatever's on the top over here on the given will always be on the bottom of the moles ratio. Now, our molar ratio is always gathered. We get the number gathered from our reaction coefficients. So our reaction coefficients for K is 2 and S is 1. Multiply this out. Our moles of S are going to be canceled. This will equal...
Pardon interruption. Do you have Kasha Shannon?
Yep.
Can you send her to 2100 office, please?
Yes, ma'am.
Thank you.
Another part to edit.
2100.
I don't want to shy with what?
I don't either.
Wait,
20.
That's upstairs in the bathroom.
Is it?
Upstairs.
I didn't know he was from England. That's crazy. 2400 upstairs in the bathroom.
Yeah.
You know, sound.
2100 hallway. Upstairs.
Huh?
Okay. God dang it, Mr. Baum. You got a lot to edit out now.
I know. Okay, back up here. 3, 2, 1. So, we have 1.6 moles of potassium. That's what we found. The moles of potassium. Now, but that's not what it wants. It wants to calculate the mass in grams of potassium. So we have to take it one step further. We need to follow the next step. We got the moles of B, which is potassium. Now we need to multiply by the molar mass of potassium. So, multiplying by the molar mass, in this case, potassium, where's my green sheet? Potassium, 39.098 grams per 1 mole of potassium. The moles will cancel, giving you just grams. Multiply this out, and you should get 62 point something. 39.098.
62.55.
62. 56 grams. Okay. So that's our rehash on what we did. Now we have to work the other side. We have learned moles to grams. Now we have to learn how to go from grams to moles. Okay? So that's a little bit different. It's a little more complicated. Okay. So, our next example. Our next example is a combustion reaction. I know it's combustion because it starts with a hydrocarbon mixed with oxygen, making CO2 and water. Or CO2 plus H2O. Okay, so that's our equation. All right, I'm going to erase this. Is that okay? No? Okay, so let me read the question. It says, calculate the number of moles of ethane needed to produce 10 grams of water. So we need to know the moles of ethane. So we want to know this. We are given grams. So we have to go step by step. Okay, we're given our grams. In this case, it's grams of H2O. 10 grams of H2O. We want to convert that to our first step, moles of water. Moles of H2O. So we're going to divide by the molar mass of H2O. In this case, yes, go ahead. 1 times 2 plus 16. 18 grams for 1 mole H2O. This is the molar mass of water. I did the quick calculation. So, we're going to divide by 18 grams per mole. That's the molar mass. Now, after I get that, I will get the moles of H2O.
Let's see here. Should have calculated it out.
Nope, I don't. I think it's 0.56. 0.56 moles H2O. Right? Now that I have the moles of H2O, I need to take it the last and final step. It wants the moles of ethane. So, to do that, I need to multiply by the molar ratio. Moles of H2O has to go onto the bottom. And what I'm trying to find is the moles of C2H6. I know I'm trying to find C2H6. I know I'm working from here. So I'm like, all right, the molar ratio, the numbers come from the coefficients, 6 and 2. So 2 moles for every 6 moles of H2O. Multiply this out, and we get a number, 0.185 moles C2H6. And that would be our final answer. I'm just following my pathway. Started at grams, went to moles of A, and then changed the moles to what I was trying to find. That's about it. I'm going to stop here, and then I'm going to teach you guys the rest.